Okay. So today's lecture, a couple things about getting your assignment working on GitHub. Then we have a bunch of stuff around objects, lots of vocabulary. The couple slides seem kind of jumpy. Then the last example is going over this idea of the invisible call to the inherited default no argument constructor. Such a mouthful. So if you understand like the quiz questions on slide like 37, 38-ish, then you're in a good spot. But it's less fluid compared to previous slides today. So one big thing in front of you is, can I move this out of the way? Yeah, let's move this up here today. So one big thing about turning in part 2 is that you're building on your part 1 code, yeah? Except you added a new asteroid.pde file, and that file needs to be added into two places. Like the physical file must be in one place, and then the name of the file must be in one place. You likely will have already modified the HTML file, index.html. Over here, the highlighted line 14. Originally, it doesn't have asteroid.pde, so you have to add it in. You have to be very careful of the naming here. I think by default, the file is called star.pde instead of stars. The file name and whatever you listed as here must match up. I've had 2 students so far that had some inconsistency, and then your program on GitHub won't load if that's the case. So oftentimes it's the plural, or maybe the capitalization that will get you, and they're separated by spaces. Yeah. Like that's where it's like kind of inconsistent, right? Like I guess this S should be deleted. If you copy and paste this exact line into here, it doesn't match up with what's in GitHub because it's actually star.pde. Star, no plural. Okay, that's step 1. And then step 2 is to be sure that you upload that asteroid.pde file. So when you click on the drop-down menu under Add File, you can upload your PDE file if you can find it on your computer. And the other way is to click Create New File, copy and paste your code from your asteroid.pde into there, and then commit, save, and give the GitHub a little bit of time to recognize it, and it should appear. That is, assuming it works in processing. Then it should appear on GitHub. Okay, questions on getting it working on GitHub? If you do have problems, do send me an email. I can troubleshoot those rather quickly if you do get stuck. And secondly, be sure you're using an array list for your asteroid assignment. There's that last bullet point. Let me try to bring that part up, where you have to test the distance. There was a request from Block 1 to go over that, and I have a short example in Block 6's video going over how you would organize the distance. Part 2. Here. Right, so that's like one of the last steps that you do in asteroids. If you figure out how to do that distance stuff now, here, step 7, right? This complicated thing. Then when we get to bullets, it'll be significantly easier if you figure out collisions in part 2. If your spaceship gets too close to an asteroid, you need to remove it from the array list. If you're using an array, it may look okay, and if it doesn't collide, then you're going to do lots more work to remove an element from your array of asteroids versus your array list of asteroids. I'll tell you that now. And grading these things, it's going to be a lot harder because I have to go into your code, and like with part 1, 2, Part 1, I have to go into your code and go inspect and see that you're using public and private correctly, that you're making these objects, that they're inherited. You could go around those things by making things public and avoiding a lot of the object-oriented ideas we learned. So part 1's grading will take some more time compared to previous assignments. Same goes for part 2. We've got to check that you have an array list, look at your code, and examine it a bit closer. Okay, next couple slides, lots of vocabulary reminders. Overriding, this is the idea of replacing an inherited function. You saw this in oddball with the show function. You're doing it inside asteroids with the move function. Floater class had a show function. That one remains unchanged. That is not an overridden function. It's an inherited function that's not overridden. So it's just an inherited function. Polymorphism. So this is that vocabulary word that means same name, different meaning. That's what allowed you to have one array with a whole bunch of particles inside and changing just one of them. In this program, we could have had everything be a floater and control it that ways, but I think your spaceship is separate, your asteroids are separate. I believe in part 3 you're going to want to have your bullets be separate. Then, well, actually, I guess you could mush it all together. You can put your bullets with your asteroids in one big array list, because you still need to do, well, probably not. No. Like bullets and bullets don't collide with spaceships, but bullets do collide with asteroids. So you have to do that comparison with your two array lists. Are each of the bullets close enough to each of the asteroids? That's how you get them to disappear. So polymorphism, an idea you'll see. In practice, I'm not too sure when you'll use it. Next, going over instance of. You saw this in your worksheet for one of the first lessons with inheritance. Instance of is just like is a, and when we're reading the arrows. An oddball particle is an instance of a particle. A particle is an instance of object. What is this object? Everything in Java is object-oriented. So when we create objects like a particle or a floater class, they actually, behind the hood, even though we don't tell it, Java has your new classes, particle and floater, extend objects. There's, you ever wonder why like system.out.println is the way it is? System is actually an object that controls all the system-related things. We go to its output subclass. I'm not quite sure what it is, and then you access its println function. For those that coded with Java and other places besides processing, int main static void, right? Main is an object. Everything in Java is an object. When I learned that in college, it was kind of pretty neat. Some rules of thumb about public member variables. 99% of the time, your member variables for your objects are private. Member functions are public. If you want to modify the member variables, you would likely use the member function with like set x or set y or whatever your setters are called. This stuff I'm going to skip over. It's like that 1% of the case where you don't want your member variables to be private. You have this idea of constant public. Like everyone knows that a gram is like that measure of unit. This constant keyword has it set that way, and it can be public. Well, you can't modify it. I don't know when this will come up. It's not a super big point. Like it's rather self-explanatory when you see. I don't know if we'll ever use final and static in this class. Processing doesn't really use it. Okay. So are there such things as private functions? Yes, there are. Those private functions, think about those as those are exclusive for you to use. You don't plan on other people to want to use it. For example, you write a member function and then see that it's like getting kind of lengthy, or you have parts that repeat itself that only apply within the object, in which case you may want to move some code over and wrap it into a function to use within that object. It's only useful to you while you're doing stuff within that object. Then it's likely you're going to make it private. Other people that want to use your object likely won't use it, but it's useful to you. In that case, you would have a private function. Like for you, think about it like a cheat. If you want to destroy all asteroids immediately, that is certainly not a feature you want to give the user straight up. So that would likely be a private function for you to use. And then you enter in like what, up, up, down, down, left, left, right, right, and suddenly all the asteroids disappear. So these keywords you've seen before, subclass, superclass, we've seen them throughout the slides. Extends is the keyword that hints you at inheritance. This thing is a very important point. Subclass inherits everything that the superclass has except the constructor. Constructors are not inherited. And then here, if you find yourself copy and pasting a lot from your base class while inheriting, that is the beginner mistake. When you inherit, everything is existing, although you may not see it. It's there. So again, this one reviews those three words, derived, subclass. There was one more, parent and child. Yes, so one I like using isn't on here. Okay. So constructors are never inherited. Anytime you see a question that asks you true or false, constructors are inherited, you answer false. Okay? Constructors are never inherited. And here's that last point that these following slides will go over. There is a relationship between the subclass and the superclass constructor. So this is the lengthy thing. The default no-argument superclass constructor is invisibly called when you create a new instance of the subclass. Let's go through an example and see what that means. So here in this program, we have our superclass, our base class, our parent class called superclass located here. It's similar to thingy from earlier this week. You have mynum inside, and then you have two constructors present. How do you know it's a constructor? You notice the name of the function matches the name of the class. That's a constructor. Here is your default no argument constructor. Nothing is inputted here. You set your mynum to 3 and you print it out. The two argument constructor takes in a number, so it takes in two numbers, adds them together, and assigns that to mynum, prints it out. Subclass here, extend superclass. It has its own constructor because constructors are not inherited. You have a one argument constructor for subclass. That initializes mynum to be whatever the user tells you and then prints it out. And then here we attempt to make a subclass with an input of 5 for its constructor. Let's see what happens. Okay, right here. All right, this call up here, oh, where is it? Yeah, this call is what we're going to walk through. It will see the subclass 5, so it jumps down to here and says, okay, I need to make a subclass. So it views here the computer. Then, because it extends superclass, it jumps up to run this line of code highlighted in yellow. So mynum becomes 3. That's the inherited member variable in subclass. Then it prints out 3. Then it jumps down or jumps back to the subclass, and then it asks itself, okay, what makes a subclass different than a superclass? So then it runs this constructor, sees 5, and then reassigns my num to be 5 and prints it out. That's why the output of this code segment is 3 and then 5. So stare at that for a little bit. Without knowing that invisible call to the inherited default no argument constructor, you would think the output would just be 5. But something else happens. Okay, if there was no default superclass constructor, so pretend this stuff is commented out, there's going to be an error. Implicit super constructor superclass is undefined, must explicitly invoke another constructor. So the implicit, another word for that invisible call. So your code won't work. How would we bypass the first constructor in the superclass so it just prints 5? No such thing. When you deal with inheritance, that call to the superclass constructor always happens, whether you like it or not. Perhaps not having a system.out.print there. And so a student asked, like, why is that necessary? And I think I stumbled a bit for the answer, but as a student reminded me about, okay, go back to thinking about memory, Mr. Chan, and it makes sense. So when you create an object, the computer needs to save space in memory for it, right? An object could have like a billion different things inside, but it has to reserve space. So when you initialize a object, like let's say superclass, superclass is going to be like this big, yeah? If you're building on top of this chunk of memory, right, it's going to be like a little bit bigger, like so. So when that happens in memory, you have to initialize first your base class, right? Your base class has to exist, right? It can't be undefined, even if it's defining, making all your variables 0, right? That's okay. You got to start with a solid base. Then when you go and create your subclass, your child, your whatever you inherited something from it, right? Then you stack on top of it. I should go sideways. Why don't I go sideways? Because I view memory sideways. When you build on top of it, then you can like do other special things. You can change those inherited member variables to be something other than 0. You can add in your new member variables. And because of that order and because of how memory works, that implicit, that invisible call to the default no argument constructor of your superclass must happen. You can't build an object on an undefined like base, like with a building. So I hope that makes sense on why this call must be here. So you can't bypass it. The Java already complains like, oh, no, you're building on an unstable foundation. Do not do that. Okay. Does the subclass inherit the default constructor? Okay. Kind of a trick question. What do we think? Does the subclass inherit the default constructor? So you may be thinking like, yeah, it does. It's being called. So the answer to this question may be yes. But go back to that idea that no, constructors are never inherited. Inherited is not the same as being like using it. We wrote our own. We haven't defined a no argument constructor in subclass, so the computer doesn't know what to do when it sees this line. It will call like, or it won't even call like super, right? Because it doesn't have subclass with no parentheses and it doesn't know what to do. That was like the order. If we go back here, right, this line, right, extend superclass, it has to get here, and then this and this have to match up. Okay, talked about the side, and then look over this one. Take like 2-3 minutes, think about the output. We have 2 quiz questions, like exit ticket like questions for you to look over, 37 and 38. I'll wait 2 minutes, 2 to 3 minutes for you to work on 37. I'll annotate the screen and walk you through my thought process for 37, and then I'll do the same for 38. You can private message me what you think the answer is. You can check yourself by copy and pasting into processing, but try to do so in your brain first. 2-3 minutes, go. It wasn't a formal cue to like be dismissed. It was do this work. Who just dipped? Cool. I got one student that proposed a solution. The order of the numbers really matters. You want to double check those. Two students have answered so far, or messaged me. Give another minute. Okay, so it should be time. Let me make sure my scribbles are being recorded. Click here, click here. Pen is huge. Great. So let me start reviewing how this code would work. At the very top, I'm looking at this line. I create a base class called Bob, new base class 4 and 5. So when I see these 2 arguments, I look at the constructor. Okay, I don't call this one. Instead, I call this one, because I take in 2 numbers, 4 and 5. Right now, for Bob, its number is 9. Okay, and I print that out to the screen. This down here will be my output, 9. Shoot, that's where my video is. Undo, undo. Okay, over here is where my answer is going to be. So there's 9. And then, clean this up, I go to the new stuff. I go to my derived class, my subclass, my child class. Derived class 6. Okay. Then I go here, I see, okay, derived class. Oh, look, there's a nice little comment that tells you there's an invisible called the super. So then default no argument constructor. That's what this super call does. We go to base class, we see 3. For not Bob, my num was 3. We print that to the screen here. 3. Then clear this up. We've finished the invisible call. We go down here. What is num? Num is 6. So now we override that to be 6. So we see 9, 3, and 6 appear to the screen. That is the output. Nice. That's this practice quiz question. 9, 3, and 6. Questions? Oops. Questions on this before I move on to number 38? Slide 38. Oh. Alright, slide 38, for time consideration, I'm just going to walk you through how I would approach it. Slide 38, here. So this one's a bit more word heavy, so I'm going to type out this stuff. At the first line, we see super Bob of the superclass 5. Superclass 5, okay, there. So we see building a super first. Then we initialize my int to be 5 for Bob. So this line right here, Bob's my int is 5. Sue is a subclass, okay, Sue. So then we look here, subclass, we go down to super of 3, cool. So here, super of 3 means that we create Sue's my int to be 3 at first, okay? We print out building a super, okay? Because we went into this function first, okay, made it 3, and then we go down here and print out building a sub. Right, so we're jumping all over the place. And then my second int, which is a member variable exclusive to the subclass, my second int becomes 4. Now when we print these things, we see building a super, building a super, building a sub, 5, 3, and then 4. That is the answer to this practice quiz question. Hopefully highlights the order in which these this one's not so much invisible. The super call is very explicit. But I guess this stuff we may not have seen before. The super of 3. What's going on there? It's calling your superclass's constructor with an input of 3. Okay. So that is what I have for you today. Your asteroids assignment is due along with your coding bat problem set. Let me know if you need an extension, ideally within the next couple hours, not late at night. Just highlights your procrastination, which I will not encourage. So get those done. Email me if you need help. I have office hours today, along with some club meetings to host, so it might be mildly distracting. Formally dismissed. Have a good Friday. Enjoy the weekend. See you Monday.